In this video, I want to talk about some of the concepts behind integration. So in math class, you're probably used to seeing, so this is my integral symbol from a to b of f of x with respect to x, right? And so if you were to graph this, so if you have your xy coordinate system, and let's do, so you've got your y here and your x here, and then you've got your function f of x doing something over here, right? And so what do we mean by the dx here? So this dx, right, and so you probably already know this from calculus, but it's just an infinitesimal portion on the x-axis. And so if we were, say, integrating from 0 to 5, for instance, along the x-axis, if a was 0 and b was 5, then we're just taking a little dx, starting at 0, finding what f of x is, summing that, taking that into the sum, and then moving over, and then we just keep on doing this of moving our dx all the way along from 0 to 5 and summing up what we get for each function value. And that's just what an integral is. So that's something I really want to hit home, is that this s stands for sum, right? You can think of it like that. And so that's all an integral is. So in physics, something that you'll see a lot is if you have something like this. So there's no function f of x in here. And so you might be wondering what that is. So technically, you could think of this as being a 1 in here. So if we had like a function 1, and I might do this in a different color. So if this was orange, right? And it would just be a horizontal line. And so you'd say, yeah, well, the integral of dx is just actually the integral of 1, right? So if I was going from 0 to 5, would give me this area. But oftentimes, you won't see us write it like that. Oftentimes you'll just see it like this. Maybe we won't even include the limits. And so you might wonder like, well, what does this mean? You know, if I'm going from 0 to 5. And so conceptually, what this means is that if you have no function you're integrating, if you're just adding up all the dx's, right, and you're starting from here and going to here, and you just add up all the dx's of the length of each dx, this is just going to be equal to the length from, and I'll choose another color, it's just going to be equal to the length from here to here. Right? That's all the integral is going to end up being. And so you see the length from here to here is 5. And so that's something that you'll see a lot. So for instance, if I have an integral like this, and I say dq, and so we haven't gotten into this yet, but dq is an infinitesimal amount of charge. And so I'm summing all the infinitesimal amounts of charge. Maybe I have like a ball here, and it's got charge all over it, maybe. Something like this. And so dq is like this infinitesimal amount of charge right here on this ball, perhaps, right? And so if I'm integrating all the dq's, this is going to be equal to the total charge of this ball that I have here, which is q. And so that's something that you'll see a lot, even if we don't write the limits. So technically, right, the limits on this integral are from 0 to q. But what we're actually just conceptually doing is adding up all the infinitesimal slices. So if you don't have a function here that you're not integrating, then you're just adding up all these infinitesimal bits. And that just gives you the total of whatever that infinitesimal bit is of. So as another example, if I said that I had a circle, and let's see, and I had a little dl, or ds, I'll say, ds, and I wanted to integrate all of the ds's, right? And so the circle has some radius r. So what is this actually? So the ds is just the length of this infinitesimal bit. So we're starting from here, but then we're integrating all of our ds's all the way around the circle. So if each ds has this infinitesimal length, but going around the circle, we add up all those infinitesimal lengths. Well, that's just going to be the length of the circumference of the circle, right? Which is just going to be 2 pi r. And so there's a lot of just sort of like conceptually understanding that all an integral means is you just sum up all the infinitesimal bits, and that gives you, for instance, like the ds that I have here, this infinitesimal portion of s, the arc length, right? If I had some angle, central angle here, technically this is s. So I'm taking an infinitesimal one of those infinitesimal one of these s's. If I have this infinitesimal theta coming from here, right? This infinitesimal thing, and this is d theta, this like really tiny infinitesimal angle. And so that's what an integral means. It just means you're going to add up all of the things like that. And so one last example is if I'm talking about, let's say I'm talking about a sphere, right? So maybe, and I'll do this in a, let's see, let's do it in yellow. So I have a sphere here. So this is actually 3D. Maybe I'll draw like a little bubble or something to try to show that. And so I say that a little portion of this sphere has an area of, actually, maybe I'll just pick the other one I already drew here. So we'll say this little area here, right, has an area of dA. The whole surface area of this sphere is A. That's its total surface area. But now I'm just picking an infinitesimal portion of it, and I'm calling it dA. And I ask you, what is the integral of dA? And you actually might also, as we'll see this later in Gauss's law, you'll see a little circle drawn on this integral sign, which just means we're taking it over a closed surface in this case, right? The sphere is closed. There's no way that the volume inside of it can get out of it. There's no holes in it. There's no way to get from the inner surface to the outer surface if you assume the sphere is hollow, for instance, right? So you'll draw the circle on there to be more technically correct, but we can leave it off for now. So I'm asking, if I'm integrating all the little infinitesimal dAs, what is that? Well, it's just going to be the total area of the sphere. So all the s's is just adding them all up. And the total surface area of a sphere is just going to be 4 pi r squared. So the sphere has some internal radius of r, right, inside of it. And it looks like a circle. It should be 3D. So that's all an integral is. So we'll come across this later on. And so anyways, I hope that was helpful in giving you a more conceptual understanding of what we mean by an integral when we do it in physics.